Hello again. Today I am going to show you how to analyze a V-versus-T graph when you have different types of acceleration, meaning the object is doing different types of motion throughout an entire trip. Okay, so I've labeled the graph, as you can see here, and I've also gone ahead and found the displacement, meaning the area for each of the different sections of the graph. Okay, notice that this section number 1, has two different parts because it makes sort of like a trapezoid or a quadrilateral, if you will, a four-sided figure. So instead of trying to do some crazy math for that, I am going to separate it into two easy to solve equations, one for a rectangle, which is base times height, and one for a triangle, which is 1/2 base times height. Okay, as you can see, I have found all of the individual areas, meaning all of the individual displacements. Okay, I have also taken the liberty of labeling whether or not the velocity or the direction of motion is positive or negative for each of the parts, as well as the direction of the acceleration, which is the slope of each line. Okay, so let's first talk about the motion of the object as it's traveling through these 30 seconds. Okay, so the first 8 seconds, this first line right here, is negative velocity, meaning the object is moving to the left and it has a negative acceleration. Notice if you look at the actual values for the velocities, the magnitudes are increasing. So you can say, oh, it's speeding up. Another way to look at it, like I've said before in my previous video, if they have the same direction, you know the object is speeding up. At t equals 8, which is right here, the object does not change direction. It is still moving with a negative velocity, so it's still moving left. What happens now is it changes acceleration. The acceleration now becomes positive, so that means the object is going to be slowing down. And you can see that because it's getting closer to 0. At t equals 9, right here, the object actually comes to a stop. Now, obviously, it doesn't stay stopped for very long, but it does stop. And it's going to change direction because now I'm going to have a positive velocity. So from 9 to 10, the object is moving to the right and speeding up. Notice how the magnitudes are increasing in the positive direction. At t equals 10, the object stops accelerating. Does that mean it stops moving? No. Okay, it is still moving. Now it's just staying with a constant velocity, meaning it's like driving in your car on cruise control. Okay, you're not speeding up, you're not slowing down, you're not changing direction, you are not accelerating. Okay, so it stays at a constant velocity for a good 4 seconds. At t equals 14, it then starts to accelerate, but it's a negative acceleration. Because they have opposite direction, and you could see that the magnitudes are decreasing, we know the object is moving to the right and slowing down. Okay, whenever you're describing motion, you should always describe the direction the object is traveling in, as well as if it's speeding up, slowing down, or if it moves with a constant velocity. Okay, at this next point right here, the object stops. Okay, stops moving is always occurring whenever the line touches the x-axis. So this object actually stops 3 times. It has a change in direction 3 times. Okay, so it was going to the right, it stops, it changes direction, and starts moving to the left. As it's moving to the left, it is speeding up. At this point here, it then changes acceleration. It does not change direction. Okay, it is still moving to the left, or negative velocity. Now it's going to start slowing down. It comes to a stop, changes direction again, and starts moving forward and speeding up. Okay?